Greetings of the day. Today we will be discussing about the normals of an ellipse. So already we have discussed the tangents of an ellipse. So now we will be discussing about the normals. The normals of an ellipse. Yes, you have an ellipse in standard form. It's a center and it is vertex A dash. Now if you draw the tangent at this point, any line that is perpendicular to this, we name this as a normal to the ellipse. So here the standard equation is x square by a square plus y square by b square equal to 1. It is the equation of an ellipse. So for this is your normal and this is your tangent. That is, normal is what? Where you can draw the tangent. At that point, if you draw the perpendicular to that curve, to the tangent, that is called as normal. So already we have discussed about the equations of the tangent. The same way we will be discussing about how the equation of a normal. We know the slope of these two product of the slope of normal and the tangent must be equal to -1. So the equation of normal at x1 y1. The point is P of x1 y1 is this. So at this point we are going to draw the normal. So the equation is a square x upon x1 minus b square y upon y1 equals a square minus b square. So this is the equation of normal at x1 y1. The same way you have drawn or you got the equation of the tangent. So slope, if you are taking that, the negative reciprocal of that tangent, so we get this at this point of x1 y1, the equation of a normal as a square x upon x1 minus b square y upon y1 equals a square minus b square. So this is when x1 y1 is given. So we know that as any parametric form of this equation. This is called a point form. The point form says that equation of a normal at x1 y1. That is, you know that as x1 y1 is this point. So a square x upon x1 minus b square y upon y1 equals a square minus b square. Now in parametric form. In parametric form, what do you know? Any coordinate of P is in the form of P of A cos theta, B sin theta. Parametric form, any point on the ellipse. If you have x square by a square plus y square by b square equal to 1, then this point can be represented in terms of theta. That is a cos theta, b sin theta. That is called the parameter form. So in this, now the point is what here? A cos theta, b sin theta. So that if you replace in this equation of a normal, that is a point form, you get that a square x upon a cos theta minus b square y upon b sin theta equals a square minus b square we get. So from this you can cancel this a, you can cancel this b also. What we get? Ax sec theta, because 1 by cos theta is sec theta. Similarly here 1 by sin theta is cosec theta. So we write by cosec theta equals a square minus b square. So when we know the parametric, that is the coordinates are in the form of parameters, that is in terms of theta. your equation changes to in terms of theta, that is ax sec theta minus by cosec theta equals a square minus b square. So first we have seen point form. From that point form we moved on to the parametric form. That is, when we know the parameter, we get the equation. Equation of normal in slope form. To the ellipse, x square by a square plus y square by b square equal to 1. So normally we say that as y equal to mx plus c to be a normal. Then what is the condition or condition for the normality? Yes, c square equals m square into a square minus b square the whole square upon you get a square plus m square b square, or you can get that as a c equals plus minus m into a square minus b square upon root of a square plus b square m square. This is the value of c you get. So if you replace this value of c in the equation, that will be the equation of a normal to the ellipse in slope form. That is y equals mx plus minus m into a square minus b square upon root of a square plus b square m square. So this is the equation of a normal when you know the slope of the normal. So then we say that as this is a slope form. समझ में आ गया बेटा? Example 1. What it says, if the normal at the point P of theta to the ellipse x square by 14 plus y square by 5 equal to 1 intersects it again at the point Q of 2 theta, then cos theta is equal to what? So we have to find out the cos theta equal to what. So in this we are given a point P of theta. So P of theta means your coordinates are in the form of a cos theta, b sin theta. This is your parametric coordinate. So now here the ellipse is x squared by 14 plus y squared by 5. This is your equation of an ellipse. So from this a square equal to 14, b square equal to 5. So a you get root of 14 and b you get root of 5 we get. So a मिल गया root 14 and b is root 5. So now what is here? The coordinates are a cos theta, b sin theta. So if you substitute it, so the point P is root 14 cos theta and b is root 5 sin theta. Now equation of a normal to the ellipse. Equation of a normal to the ellipse already we know that as a square x upon, here the point is a cos theta minus b square y upon a b square y upon b sin theta equal to a square minus b square. So we have the equation of a normal to the ellipse as a square x upon a cos theta minus b square y upon b sin theta equals a square minus b square. This is the equation of a normal. So if we substitute the value of these values, that is, it is normally general equation of a normal. In this, a cos theta means root 14 cos theta and root 5 sin theta, that is substituted, and a square we know 14 and b square is 5. So if you substitute it here, 14x upon, you get root 14 cos theta minus 5y upon root 5 sin theta equals a square is 14 minus This we get. So now from this you get root 14 x upon cos theta minus root 5 y upon sin theta equals 14 minus 5, 9 we get. So this is your equation of a normal. So now what it says, that is, it intersects it again at the point q of 2 theta. So q of 2 theta means the coordinates of q are a cos 2 theta, b sin 2 theta. So these are the coordinates of q आपको मिलेगा. So this point means what? You get q as root 14 cos 2 theta, root 5 sin 2 theta we get. So this point also lies on this, because this line meets the ellipse again at this point. That means this point lies on this line. So this point lies on this line means what we will get? Root 14 into root 14 cos 2 theta divided by cos theta. Okay, if you substitute x equal to root 14 cos 2 theta minus root 5 into y is what here? Root 5 sin 2 theta. So root 5 sin 2 theta divided by, you get sin theta equals, you get 9. Because this point q of root 14 cos 2 theta, root 5 sin 2 theta satisfy, or this line is intersecting the ellipse or the curve at this point also. So this point also satisfies this equation. So we replace that values. Now that means what? 14 cos 2 theta by cos theta minus 5 sin 2 theta by sin theta equals 9 we get. Now 14 cos 2 theta by cos theta minus 5 sin 2 theta by sin theta equal to 9. That is 14 cos 2 theta by cos theta minus 5 into 2 sin theta cos theta by sin theta equal to 9. Because you know sin 2 theta is 2 sin theta cos theta. So this sin theta get cancelled. And cos 2 theta also you can write it as 14 into 2 cos squared theta minus 1 upon cos theta, or you can take LCM. If you take LCM as a cos theta, you get minus 10 cos squared theta equal to 9 milli. So now from this you get 28 cos squared theta minus 14 minus 10 cos squared theta equals 9 cos theta. Or if you are simplifying these two, you get 18 cos squared theta minus 9 cos theta minus 14 equal to 0. So we get 18 cos squared theta minus 9 cos theta minus 14 equal to 0. Now it is a quadratic in cos. Now how to factorize this one? So 18 cos squared theta, the sum is minus 9 and the product is 18 into minus 14. So we get here minus 21 cos theta plus 12 cos theta minus 14 equal to 0. So if you are factorizing, so this will give us 6 cos theta minus 7 into 3 cos theta plus 2 equal to 0. So we have this. So from this what we get? 6 cos theta minus 7. 6 cos theta minus 7 equal to 0. Cos theta equals 7 by 6. That is more than 1. That is not possible. The another one we have 3 cos theta plus 2 equals 0. So cos theta equals minus 2 by 3 we have. So from this what we get, this is possible because this is less than 1 and we know that as a cos theta value lies between minus 1 to 1. So cos theta value is minus 2 by 3. So what we have got, the value of cos theta is A, it is not minus 2 by 3. So the B option is the right one. So what we have done in this, so first we have taken the normal to the ellipse at a point P of theta. To the ellipse here, x square by 14 plus y square by 5 equal to 1. So first we have got the equation of that one. So that is intersecting again to the ellipse, or this line is meeting at this point q of 2 theta, that is A cos 2 theta, B sin 2 theta. Then from there we got the equation of this. So this you factorized and we got the value of cos theta is what? समझ में आ गया बेटा? Now let us move to the example 2. What it says, the equation of the normal to the ellipse x square by a square plus y square by b square equal to 1 at the end of the lattice rectum in the first quadrant is this, we have to check it. So we know that as it is an ellipse, its lattice rectum means it is passing through the focus, that is AE comma 0 L L dash. So we are going to draw the normal at this point, that is at the end of the lattice rectum, at this end point of the lattice rectum in the first quadrant. So if we draw the normal, then what is the equation of this? Equation of the normal at this point of this one. So this one AE. So what will be the coordinate of y? So if we substitute in this, a square e square by a square plus y square by b square equal to 1. Here you get y square equals b square into 1 minus e square. We know that as b square equals a square into 1 minus e square. So this gives us y square equal to b square into b square by a square. So from this we get b squared by a. So the coordinate is b squared by a. So what we get at the end point of a lattice rectum, the coordinates are AE b squared by a. Now what we have to find out? The equation of the normal. So the equation of a normal is what? Normally we have a square x upon x1 minus b square y upon y1 equals a square minus b square. This is the equation of a normal. Now what is here x1 y1? x1 is AE and y1 is b squared by a. Now if you replace here, a square x upon x1 is AE minus b square y upon y1 is b squared by a equals a square minus b square. Now from this one a get cancelled. Similarly here b square get cancelled and this a go up. So the equation becomes ax upon e minus ay equals a square minus b square. Now if you take LCM, so we get ax minus aey equals e into a square minus b square. Now here the answer we have nothing is involved with b. So we have to change that value of b square is what? So e into a square minus of a square into 1 minus e square, because we have here b square equal to a square into 1 minus e square. So this gives us e a square minus, if you are taking inside, you get e a square plus e a square e square we get. So if you multiply this e a square, then if you take it inside, so minus e into a square minus minus plus e a square e square, or you can write this as a square e cube. Now these two get cancelled. So a squared e cube. Now bring that into one side. That is ax minus aey equals a square e cube. Throughout a can be cancelled. So x minus ey minus a e cube equal to 0. So now what we have? What is the equation? We have the option. So e x plus ey, but we have here x minus ey. So x minus ey, but here it is plus, there it is minus. Now what we have? Another one, x minus ey minus ae cube equal to 0. So this will be the right option. So what we have done first? We have taken the coordinate of the end point of the lattice rectum, that is ae comma b squared by a. At this point you got the equation of a normal. So this only you are simplifying and bring into the form of x minus ey minus ae cube equal to 0. समझ में आ गया बेटा? Now let us see what is the example 3 says that. The condition that the line x cos alpha plus y sin alpha equal to p may be a normal to the ellipse x square by a square plus y square by b square equal to 1. Then what are these options which is suits this question? So let us take that as let the theta. Okay, that means the point P as a cos theta, b sin theta be any point on the ellipse in parametric form. So now what is the normal at this point we get? So we get the normal at this point as a square x upon a cos theta minus b square y upon b sin theta equals a square minus b square, or in other way around you can write a x sec theta, because 1 by cos theta is sec theta minus b, 1b get cancelled, here 1a get cancelled. So by cosec theta equals a square minus b square we get. So let us assume this is the equation 1. Now what is given? The line x cos alpha plus y sin alpha equal to p is a normal. X cos alpha plus y sin alpha equal to p is a normal given to you. Now at this point theta, this is a normal. If this is a point, this you get this equation of a normal. So if at the same point, if this is a normal means, then we say 1 and 2 are identical. That means they are same equation we can say. So if they are same means we can comparing both these equations, compare it. On comparing, what you get, a sec theta upon cos alpha, that is coefficient of x you see, and here coefficient of x you can see that. And similarly here, that is equal to minus b cosec theta upon sin alpha equals, here the constant is a square minus b squared by p we get. So what we get the equation, these two equations we compare it. On comparing the coefficients of x, y and a constant, we get this relation, that is a sec theta by cos alpha equals minus b cosec theta by sin alpha equal to a square minus b square by p. So from this we get a sec theta by cos alpha equals a square minus b squared by p. Sec theta means what? 1 by cos theta. So from there a by cos theta cos alpha equals a square minus b squared by p. Or we can get cos theta equal to pa by a square minus b squared cos alpha. we get cos theta equal to Pa upon A square minus B square cos alpha. Similar way, from this we can get what? So minus B by sin theta sin alpha equals A square minus B squared by P, or we get minus BP by A square minus B square into sin alpha is sin theta. Now we get cos theta equal to this and we get sin theta equal to this, and you know that cos square theta plus sin square theta equal to 1. So sin square theta plus cos squared theta equals, that means you square this and add it. So both you square it and then add up. So if you are adding up, what you will get? P square A square upon A square minus B square the whole square cos squared alpha plus B square P square upon A square minus B square the whole square sin squared alpha. Now squaring and adding, that is these two you can square, that is cos theta equal to this and sin theta equal to this. If you have squared these two and add up, we get sin square theta plus cos square theta equal to this. Now we get this one equals, that side what we have? P square A square upon A square minus B square the whole square into cos squared alpha plus B square P square upon A square minus B square into sin squared alpha. Okay. So now from this you can take this A square minus B square whole square for this side you can take, that is A square minus B square the whole square equals, from these two you have a common P square out and left with this here A square upon cos square alpha. A square upon cos square alpha can be written as A square sec squared alpha plus here what is left? B square upon sin square alpha, that means B square cosec squared alpha. So now we got this relation or the condition that this to be the normal to the ellipse. X square by A square plus Y square by B square equal to 1. What is the condition? A square minus B square the whole square equals B square into A square sec square alpha plus B square cosec squared alpha. So your option is A. So what we have, how we got this condition? First what we have taken? Any point and the ellipse, that is P of A cos theta B sin theta. It's the equation of normal, we got it, and then what is given? This is the normal given already. So we compared these two equations because these two are one and the same, or we can say identical. From there we get the relation of cos theta is what, sin theta is what. So from that relation what we get are the condition of y x cos alpha plus y sin alpha equal to P to be the normal to this ellipse is A square minus B square whole square equals P square into A square sec square alpha plus B square cosec squared alpha. समझ में आ गया बेटा?